Thank you. And the perfect segue into Michael's talk about DevSecOops, a topic very close to my heart.
Thank you, Hannah. Is this on? Hello? Check. There we go. All right. Thank you. Hi, I'm Michael Ducy. I'm going to talk about DevSecOops. 15 years of DevOps days and patching is still horrible. So a little bit about me. I used to organize DevOps Days Columbus, and I helped launch a few others in the United States as well. I do live in Ohio, and I do have a DORA area. We'll talk about that here in a second. I also was a CNCF Falco maintainer for about 3 years as well, and in the past worked at Chef and Sysdig, and now I'm currently at Red Hat where this story takes place. And some other interesting things about me if you want to talk about woodworking or any of those other topics. So yes, this is a DORA area. Basically, the outline is where you're allowed to carry around a drink, right? A very weird concept, I understand. And the orange points are where you can buy a drink, and then the red are signs that say you're about to leave the DORA area and you'll be immediately arrested on spot. So yes, they do exist, and I understand it's a bit of a weird concept. So let's go to the topic at hand. So why this topic? A customer came to us and said, we scanned our OpenShift clusters with a vendor, security vendor tool. There were over 7 million instances of CVE present. So security is going to move to black hole these clusters if we don't have a plan for remediation within a couple of weeks, right? And so, 7 million CVEs, where do you even begin to start to investigate? Well, it wasn't 7 million CVEs, but 7 million instances of a CVE. Where do you even begin to start to investigate that? Well, let's go back to this topic of DevSecOps. So what is DevSecOps? So we've talked about this for a while in the community, and really the way it got started is this idea of shifting security practices and principles further left into the development lifecycle, right? It was created, feel free to choose more than one if you want, because security felt left out of DevOps. Security is a special flower that thinks that they're not operations. Developers don't care about security, so you need to explicitly call it out, or otherwise they forget. I think more importantly, marketers needed a way to make their products relevant, was another reason. And DevOps is just a made-up word anyway, so we can add anything we want to it at any point in time. But the way it really got started was this slide. I'm sure a lot of people have seen this slide. This was created by Pete Cheslock in a talk that he did that really kind of started this concept of DevSecOps. But really what we've progressed to is something more like this, right? We're still shoveling rainbows, but it's just a different person that's giving us those rainbows now. So let's go back to the scan results. So the customer asked us to analyze the results. They asked us to look at only critical and high CVEs. They only wanted us to review the app platform components or the OpenShift components that were maintained by Red Hat. And then they wanted us to deliver a remediation plan on what they should update, retire, replace, et cetera. The limitations were we didn't have access to this tool that they used, so we couldn't actually see the scan results. The way that we actually got the scan results was through a support ticket. There were about 4,000 rows and 41 columns, so quite a big data set to go through to start analyzing these CVEs. So how do you begin to start to analyze this data set? Can anyone guess? Perl, well, that's a good one. Yeah, you could go to the command line, you could go to Perl or something like that. Thank you, yes. Enter Captain Excel. Still very useful, as a result of this, I've had a lot of people ask me, can you teach me how to do pivot tables? So for whatever reason, I'm a manager now. For whatever reason, I'm the one who got called in, or I'm the one who took the lead on actually helping ProdSec go through this and actually figure out what we needed to patch. And it was mainly because it was my customer and I have the background in security from my previous work. So enter Excel, or Sheets more appropriately, to the rescue. And yes, I am using PowerPoint. I know it's kind of like not accepted anymore, but there's a good reason why, and I'll tell you about that here in a second. So Excel is still really the easiest way to analyze data. You can load up different types of data. You can actually pull in data from actual remote sources as well. And pivot tables are this magical tool that really allow you to quickly group the scan results, either by repo, namespace, CVE, the actual individual package. You can create multiple pivot tables if you want to group things a little bit differently as you're doing your analysis. And then I think the other thing that's really important is you could quickly filter out results that you don't want to analyze or you do want to analyze, right? So we could very quickly filter out the criticals and highs, and we could also filter out the Red Hat maintained namespaces, right? So things that we know that are core OpenShift components or Red Hat maintained software, we could filter those out very quickly. And so this is what the pivot table looks like. So in this case, or a snapshot of it, because it was very large, especially as you start to expand it. And so you can see here that we basically take the package, and then we want to see what CVEs are involved or in that package. Then we can see the namespace, and then you can take it one step further where you can actually see the repository where that's being pulled from. And then if you wanted to take it one step further, you could actually find out like what host it was actually running on and things like that. But these views were actually enough for us to really start to analyze the data and figure out what was going on. This is another view. It's organized a little bit differently. In this case, we're organizing it by namespace and then the repository, and then it allows us to see what CVEs are actually present inside of that repository for this particular SHA that we're analyzing, or that particular container image that we're analyzing. So findings for the app platform side of things, what we found was there were 20 critical CVEs and 69 highs that were identified in the app platform. This amounted to about 168,000 instances of the CVEs. And the very interesting thing was that 95% of the findings were false positives, right? So one of the main things is that the vendor was unable to parse the RPM names. Everybody knows that RHEL, for the longest time, has kind of, the way they name Python packages is different than how Python actually maintains those packages or names those packages. And so, something that's been going on in RHEL for 25 years, right? The vendor was still unable to handle that kind of situation, right? And then the other big critical thing was that the vendor was unable to identify Golang packages correctly, and so then, of course, Go is the glue of Kubernetes, and so therefore it's kind of an important thing for you to be able to analyze, especially if you're selling a tool to people to analyze Kubernetes clusters, right? And of the critical CVEs, there were actually only one critical CVE that we found that was genuine, and it was 2 containers, and it was containers that were running backstage that the customer had not taken the latest Z-Stream release, which patched those issues. So what this looks like graphically, we also were able to kind of look at this from this perspective as well, to what this looks like graphically. So you can see that there's about 165,000 vulnerabilities identified just because of these 2 problems that were basically false positives, right? And so basically the file they gave us just had a lot of noise, and we needed to really kind of analyze, get through that noise and find out what was real and what wasn't, right? So some outcomes from this. So the customer ended up using another vendor to scan the same cluster. That scanner was actually certified by Red Hat, which is important mainly because an issue that I'll talk about later, but Red Hat doesn't necessarily agree with what NVD says all the time for a vulnerability rating, and that's for a number of different reasons. And so having a scanner that we actually work and partner with that company to actually help them pull in our data and our data feeds is important. There were 0 critical issues identified in the actual app platform components, except for that one that I mentioned. Or actually, in the new scan, there were 0 critical issues. They did go and update some things between that scan and this scan. And then what we found is most of the high CVEs that they were worried about were fixed in a Z-Stream release that they hadn't taken yet, or Red Hat was aware of them, and we were meeting our SLA, and there were fixes in the release cycle for upcoming releases for the particular software. We worked with the original vendor to help them fix their false positives. Our ProdSec team was actually working with them to certify their scanner as they were kind of going through this, and this is obviously one of the glaring things that we found that they needed to fix. And then what the other outcome was is the customer ended up dropping the original vendor as well. And this was for a number of reasons, not only the scan results, but the vendor tooling ended up causing a production outage and degradation of service. And this is a company that basically is 24/7. They're a global company around the world, and they constantly have operations going on to where they actually need these systems up and running. And this runtime protection tool basically was getting in the way of different networking things as it was analyzing network traffic. All right, so this kind of opens up the question of, does patching still matter, right? So should we be doing this scanning? Should we be really, how do we analyze those results? We kind of talked about that, but with everything that's changed in the last 15 years, can we approach patching maybe a little bit differently? So patching still matters, of course. We have to have critical CVEs fixed. But I think the important thing is, and was one of the things missing with this customer, is that they didn't understand our software lifecycle at Red Hat, right? And so we had to do a lot of education to the customer to help them understand what that software lifecycle looked like. For critical CVEs, often critical CVEs aren't disclosed until fixes are available. And so those fixes will be readily available from day 0 or day 1 when that vulnerability is released. Vendors often provide SLAs for fixes, so we have a life cycle for highs and importance, and sometimes we also have things that we won't fix for various reasons as well, and you need to understand why the vendor won't fix something as well. And then, of course, you need to develop your upgrade strategy and plan based upon this vendor's SLA of when you can expect patches coming from the vendor, and I think the most kind of common one that we see is Patch Tuesday, right? Where Microsoft, I haven't maintained Windows in a long time, so please correct me if I'm wrong, but they used to occasionally on Tuesday release patches, right? Once a month, something like that? Second Tuesday of the month, thank you. Thank you, Yas. You need to understand the NVD severity rating versus the software owners. So one of the things that we were getting hit on is that, well, this is a critical CVE, and well, Red Hat actually looked at it as a high CVE. And part of the reason why is because we often include libraries and we're only using one function or one class or one method from that particular library. So for example, if there's like a networking vulnerability to where it's not parsing URLs correctly, if we're not actually using that part of the library, we rate it differently because the ability for that code to be exploited is much harder, right? I think also important is you have to understand the blast radius of the CVE. We have a lot of things, which I'll talk about here in a minute, that's helped improve understanding that just because one system is vulnerable, where can that attacker go from there, right? Is it a system that's connected directly to the internet with a critical vulnerability? Because that's much different than something that's 5 layers back in your data center. So what we do find from these results with this customer is that applications are still a very heavy lift. So there were 7 million instances of CVEs in these scan results. We only found 168,000 that applied to Red Hat maintained software. So that other 6.8 million is out there in their application code and application libraries and application containers, right? And I think this is where the sweet spot for DevSecOps is helping those developers understand that pulling in patches should be part of the software release cycle, right? You should be updating your containers. You should be updating that application code as well, especially to the latest Z streams, because that's where often security fixes are. Hopefully, if you're using VMs by this point, VMs are short-lived, and so I think this is one of the things that's really important to understand is that we don't always have long-running systems anymore, right? If we've adapted to this DevOps model, if we've adapted to the cloud model, we should be constantly rebuilding our VM images, pulling in those security patches, reinstalling the application, and standing the machine back up. and then having the application run from there. And I think one of the important things is that things like Kubernetes and app platforms, and Tecton and all of these tooling, we can actually leverage those things to actually help us with our VMs. And I think we tend to forget that maybe those tools are only for the Kubernetes world, but they can also be used to help maintain your VMs as well. And then longer VMs, given to advances in technology, long-lived VMs can be isolated or in some ways modernized. And I think one of the projects that we're really bullish on at Red Hat is KubeVirt, because what it really allows you to do is provide these Kubernetes principles to further isolate the VMs, right? So you can do pod security policies. VMs actually run inside of a container and they get all of the isolation principles of the container. You can apply networking policy as well to create zero trust networks so that the VMs can only talk to who they need to, and so forth. So does patching still matter? No, and I mainly say no because a lot of the advances in the last 15 years help us mitigate CVEs without patching, right? So I think one of the biggest Kubernetes principles is this idea that you can apply zero trust networking by default. Containers or applications can only talk to the applications that they need to, and they can't get more access than they need. You can leverage also these isolation principles as well. So knowing that just because a container, if there's a breakout of the container and they get to the host operating system, you still have things like mandatory access control, like SE Linux and AppArmor. You have SecComp, you have cgroups, and you have other methods that are being used to help prevent attackers from taking over that system. And I think more importantly, we've also shifted a lot to read-only container-based operating systems, to where that operating system or that worker node is ephemeral. It can be recreated very easily by Kubernetes and by you if you go and delete that node. And then runtime protection as well. So don't use that one particular vendor that I mentioned earlier. I'm anonymous because they are a partner, so I can't necessarily diss them publicly. But there are things like runtime protection, that's what Falco did or does, is where you can actually see in real time who's actually running things on a system, who's actually running commands. Is all of a sudden a container starting to install RPMs? Because then, there's obviously somebody in there installing RPMs, or a vendor or a developer is doing something very bad inside of that container and having RPMs installed. And then I think the other advance is, having this idea of unprivileged containers to where you can actually run it as an actual user and providing that further isolation of the operating system. So, conclusion. I think we still have a ton of work to do integrating security team into modern operations. One of the big things we found with this customer is we had to educate the security team a lot on the principles of OpenShift and the principles that OpenShift apply to make your applications more secure, and kind of going back to that slide, why a CVE may not necessarily matter as much. I think another key thing is that you need to ensure that you're using modern architectures and practices to help mitigate these vulnerabilities. When you do get these scan results, you need to prioritize them, critical CVEs first and public endpoints first, and then work your way back into the environment. As I said, the advances over the last 15 years can help mitigate these problems. And I think another important thing is if you're running in the cloud, this is one of the advantages of using cloud services and decoupling things and running it inside of that cloud service, because it's one less piece of software that you have to maintain. And that is also, the services that you're running are probably much more critical sometimes than the application code itself, right? So think of a database, and if a VM running a database gets hacked, people have access to it, where if the database is actually running in the cloud service, there's much more layers that they have to get through to get into that actual database. And then I think very important, and I know this is maybe a little biased because I work at Red Hat, but you really need to work with your vendors and use those vendor relationships to help manage these fixes that are coming into the free and open source software that you're using. So whether if it's working directly with those development teams that are maintaining that open source software, or working with somebody downstream like us, it helps a lot. And I think one of the problems is the number of projects out there today, especially just in the Kubernetes ecosystem, it can be really untenable for a security team or a operations team to keep up with all of these fixes. And then I think the other thing is use that tooling that your operating system vendor provides or your vendor provides to help manage these updates and fixes as well. So with that, thank you very much. Since we're short on time, we can skip questions, but I'll be around the next couple days.